Hello and welcome back to Introduction to Astronomy. And so in this segment we're going to learn about the force of gravity. And so what I need for you to do is to get onto the internet and then type in Gravity Force Lab PhET, P-H-E-T, and open up that simulation, and then if you can, have it side by side with this lecture, so that you can work on the simulation and you can be listening to me at the same time. So when you open up the simulation, you're going to see that picture there that's at the bottom. It's got a ruler, and then it's got two balls, and then there's two people pulling on the balls. And you can change the distance that the two balls are from each other by clicking on one of the balls and then pulling it. You can also change the mass of the balls by moving the sliders down there at the bottom. Okay, so we're going to just do some little experiments with this simulation, and our goal is to come up with a formula for the force of gravity. Okay, so first thing I want you to do is you notice that there are two sets of numbers up at the top. And so one is the force on ball 1 caused by ball number 2, and then the other one is the force on ball 2 caused by ball number 1. And what do you notice about those two numbers? Okay, they're the same. So why would those two numbers be the same? In the previous lesson, we learned about Newton's laws of motion, and we learned in particular about Newton's third law, which said that for every action there's an equal and opposite reaction. So that means that if ball 1 pulls on ball 2, then ball 2 has to pull on ball 1 with an equal and opposite force. So that's the reason why those two numbers are the same. So for the rest of the experiment, just ignore one of those numbers and just concentrate on the other one. All right, so our first little experiment that we're going to do is that I want you to, on a piece of paper, write down what is the current force acting on the two balls. So just jot down on a scratch piece of paper what the current force is. Okay, now I want you to double the mass of ball number 1, and I want you to see what effect does that have on the force of gravity. Okay, and you should have noticed that it went up. Okay, so that's the first thing that you should notice, that if you increase the mass of one of the balls, then the force of gravity acting on the two balls increased. So I'm going to give you a little algebra here, and I hope I'm not going to scare you off with this, but let's write that here is the force of gravity, and I'm going to give you two possibilities for the force of gravity, and you tell me which one makes more sense. Okay, so we could say that it's proportional to M1, the mass of ball number 1, or the other possibility is it's proportional to 1 over M1. So what would be the difference in putting the M on the top versus the M on the bottom? Okay, now here's again some algebra type stuff. You can do this with your calculator. So 1 divided by 1 is a 1. And then 1 divided by, let's say, 4 is 0.25. So did you notice that if you made this number in the bottom part of the fraction bigger, then what came out got smaller? Okay, now is that what happened? So when you increase mass number 1, what happened to the force of gravity? Did it increase or decrease? Okay, it decreased. So that's telling me that this is not correct. Okay, and so it's going to be this one here. Now at this point we don't know whether it could be the square root of that, or maybe it's M1 M1 squared? So we don't know. But there's this very simple way of figuring that out. Did you notice that when you doubled M1, what happened to the force of gravity? It doubled. And so that's telling me it's not a square root, and it's not a square. It's just plain old M1. So if you multiply this side of the equation by 2, then according to algebra, you have to multiply this side of the equation by 2. Okay, now let's try it for M2. So this time, don't change M1, but I want you to double M2 and see what happens to the force of gravity. And it did what? It doubled. Again, just like M1 did. So what that's telling us is that it's M1 times M2. So if you double M2, it doubles the F. If you double M1, it doubles the F. So this is the way that real scientists actually go about doing stuff. That they don't necessarily know what the formula is to start with, but they've got their data, and then based on the data, it gives them ideas as to what the formula is. Let's try one more thing. Okay, this time I don't want you to change M1, and I don't want you to change M2, but I do want you to separate the balls. So separate the balls and see what happens. Okay, did you notice that the force of gravity got weaker when you did that? Okay, now where should we put distance? So the distance between the balls, we're going to call that R. Where do you think it should go? And don't look at the formula, which is right at the top of the page. I guess I shouldn't even said that, okay? It needs to go in the bottom part so that it's M1 times M2, and then we're going to divide by R. Now I'm not finished yet, so I'm dividing by R. So then that way, if you increase the R, it decreases the F. But that's not quite it yet. It's not just R. It turns out that it's R squared. Now later we're going to find out exactly why does it have to be R squared. Now you can verify this by using the ruler and doubling the distance. So what's 2 squared? That would be 4, but it's in the bottom part, so it's 1/4. So you should notice that the force of gravity decreases to 1/4 of what it was before. So here's our formula so far, that the force of gravity is proportional to the mass of mass 1, the mass of mass 2, and then divided by the distance between them squared. And to make it so it's an equal sign instead of a proportional sign, then we need a constant of proportionality, which turns out to be big G. So big G is a fundamental constant of nature called the gravitational constant. And I gave you what its number is, 6.67 times 10 to the negative 11th power. Do you notice it's a very small number? So what does that mean about gravity? Gravity is actually the weakest of the 4 fundamental forces that control the universe. And so we'll find out more about that later in the course when we discuss all of the fundamental forces together. Okay, so let's do a math problem involving this formula for the force of gravity. So you got these 2 objects. If 2 objects get 4 times further away from each other, what happens to the force of gravity? So the 2 objects start out like this, and then they have a certain force, and now they're going to be 4 times further away from each other. What's the new force of gravity? Okay, so instead of r, we're going to put 4r, so 4 times the distance. And so there's going to be some students that would say, oh, the gravity is going to go down by a factor of 4. Not quite, almost, because you got to square it. So 4 times 4 is 16, so therefore it's going to be 1/16 as strong, or you could say 16 times weaker. So either one of those answers would actually be correct. So don't forget to square the distance. While we're at it, let's do one more before we take our break. And let's try this one. This time we're not going to change the distance, but let's say that M1 got 5 times bigger. What would be the new force of gravity? And you would say 5. So it's 5 times greater. That's too easy. All right. So let's say that one of them gets 5 times bigger and the other one gets 3 times bigger. What's the new force? Well, it's going to be 8. No. M1 times M2. So it's going to be 3 times 5, and so that's going to be 15. So the gravity is going to go up by a factor of 15. Okay, so when we come back, we're going to apply this concept of gravity to the tides. I'll see you in just a moment.